Hello, Space Cadets, and welcome to Mueller Planetarium Astronomy at Home. This is Zach Thompson, Planetarium Coordinator at the University of Nebraska State Museum at Morrill Hall in Lincoln, Nebraska, wishing you all clear skies. Today we're going to explore meteor showers. We'll be using two programs, meteorshowers.org and Stellarium. You'll find the web addresses for both on the right-hand portion of your screen where our Comet buddy is holding them up. To understand meteor showers, we first need to explore comets. We'll use meteorshowers.org first, a visualization program. Comets are the leftovers, or the remains, of when our solar system formed about 4.5 billion years ago. They are loosely held together objects of ice, rock, and dust. Think of them as dirty ice balls. Comets exist in two general areas of the solar system. The first is a region beyond the orbit of Neptune here, this dark blue circle, and this area is called the Kuiper Belt. Within the Kuiper Belt, by the way, one of the largest objects there is the dwarf planet Pluto. Farther still, in a shell surrounding the solar system, is the Oort cloud, O-O-R-T. Oort cloud, and this is the other place where comets are generally found. What happens is a nearby star could nudge with its gravity one of these objects loose and inward toward our star, or our sun itself can pull one of these objects free and bring it in towards it, into the inner solar system. Here we see a comet in this stretched out shape, an ellipse, being pulled inward towards the sun, and as it gets closer, the sun's energy heats it up and bits of it start to break apart. It's also during this time that a nice, beautiful tail can form behind the comet. When the comet gets close enough to the sun, a few things can happen. Either the comet gets completely vaporized or destroyed because of the sun's immense gravity, or it survives and it stays in this elliptical orbit for a very long time. But for every pass the comet makes around the sun, it erodes, it wears away a little bit more. And we see this material of the comet shown in these white flakes here, all around. But this debris follows the orbit of the comet, the same orbit that the comet took. Here is the Earth as this light blue circle, and occasionally our Earth goes through a trail or stream of this cometary debris. It's during this time that we can experience meteor showers. Now, on any given night, with clear dark skies, you could see a handful of meteors per hour. But it's during a meteor shower that our Earth picks up more debris, and you tend to see a bit more than just a handful. This orbit right here is in fact the orbit of Comet Halley, the famous Halley's Comet. And it is this comet that brings us in early May every year the Eight Aquarians meteor shower. But what does this look like here on Earth? Let's open up Stellarium here and explore a bit more. With Stellarium, it identifies areas of the sky that you could see meteors, or in particular, meteor showers. We're talking about the Eight Aquarians at the early portions of May. You'll find over here to the east-southeast what's called the radiant. And this is where all the meteors in this shower appear to come from in the sky. They radiate outward from this region. Meteor showers get their name from where they appear in the sky. So in this case, Aquariids comes to us from the constellation Aquarius, or the water bearer. So that's where the radiant is located. Not all meteor showers are the same. They're different. Some are better than others, meaning some put on a better show than others because there's maybe more space debris, or conditions are a little bit better or less favorable for one or another. But that's part of the fun of experiencing a meteor shower. Let's take the Eight Aquarians for example. On average, one could expect to see 20 to 60 meteors per hour. However, this particular meteor shower, where the radiant is, in the northern hemisphere, does not get very high up in the sky. Because eventually, shortly thereafter here, this is the very early morning, the sun is coming up right behind it. So there's not a great window to see much. The higher the radiant is in the sky, the better the show is, by far. However, our friends in the southern hemisphere can see this a bit better. So usually for them, this tends to be a better show. What you also need for a meteor shower are the right conditions. Clear, dark skies. And what you absolutely never want is a bright moon in the sky, which is the case during 2020's Aquarians meteor shower. That kind of brightness is light pollution we don't want, and it washes away the show. So the darker, the better. But this is a regular occurring meteor shower, and there are several throughout the year, because the Earth goes through these trails of debris from various comets. Now let's briefly look at a very famous one in the mid-portions of August in the northern hemisphere. During the summertime, we find the wonderful Perseids meteor shower. This is known to even casual observers because it's a very rich meteor shower. On average, you could expect to see at least 100 meteors per hour, again with the right conditions. Now, you can see that there is a moon out here low in the sky during the height of the Perseids, but it's a crescent. It's a very sliver of a moon, which means you won't have all that pesky light pollution to get in the way. So that is definitely in your favor. As we see, here's the radiant. It's called Perseids because it comes from Perseids. You never need binoculars or a telescope when you're out looking for meteors, especially during a meteor shower. You just need a wide open space, clear dark skies, and just watch for these little flakes of light that come and go seemingly at random, but then you trace them back and you see where they're originating from in the sky, which is part of the fun as well. What's happening is the Earth is picking up all of this material and it's burning up in the atmosphere very fast and burning up because of the friction in the Earth's air. So what does the Perseids look like using meteorshowers.org? Let's just compare them with this program here just to see the difference. Here is the Aquarians, and then we have a drop-down menu, and we click on Perseids for mid-August, and suddenly you see why that meteor shower tends to give more of a show than others do, because it's a dense stream of material coming to us from Comet Swift-Tuttle. And this information can be found in this pop-out menu in the upper left of the screen. So you see, we go through this thick region of debris, we get a better show, but all the meteor showers, they are different, they're unique in their own way. Now, when you're stargazing, write down your observations and see what you can find in the way of meteors. How many can you find? What part of the sky are they coming from? And what time? Is it the very, very late evening hours that you saw a couple, or is it the very early morning hours? You tend to see a bit more in the early morning hours for what it's worth, but it is fun hunting for meteors, and you never know. One bit of space debris could be a little bit bigger and brighter, which just means it lasts longer and it's more visible in the sky before it completely vaporizes. So it is a lot of fun, especially when the weather cooperates and conditions are just right. It takes a little bit of planning ahead, but it's all part of the beauty of the evening skies. If you have any questions, please leave them in the section below. Until next time, Space Cadets, keep looking up.